Okay, thanks. It's my honor to introduce the inaugural talk by Abram Demski on the partition assumption. I think we've had really a lot of great conversations about agency for many years. And I think looking back on those conversations, I realized that I have understood almost nothing about them, which is some sort of progressive understanding. So, but I really hope I'll learn something today. And no, but less funny. I do think this is sort of the theme of this conference. I think is closest to what Abram has been sort of shouting for years. So hope this is the start of something good. Okay, I'm gonna put the.
How long do we have?
You have an hour, but we start. Yeah, don't worry about it. I'll keep track.
You'll keep track.
Yeah.
Maybe I'll just have this anyway. Yeah. So my talk is about the partition assumption, or the assumption of partitional evidence, or the evidence partitional assumption. And so some kind of rough motivation for why I'm talking about this. First of all, this is not me updating everybody on my research, really. Like, the prompt I was given was more like, talk about some classical decision theory things. But of course, this is something I'm reading about because it relates to things I was thinking about, so there's that. But the kind of rough picture of why this might be at all connected with what we're doing here. So, like, one general theme within like embedded agency or naturalized agency is this kind of questioning the agent boundaries, questioning how we think about input and output for agents. But if, as we are planning to do here, we are examining that through the lens of these like classical representation theorems, and like trying to move that forward, then I fear that there is a sort of bias to focus on the output side of that, the action side of that. For example, if we are looking at the Jeffrey Bulker axioms versus Savage's representation theorem, then it really foregrounds this question of how do you represent actions. In this talk, I want to foreground the question of how you represent the inputs, the observations. But in order to do that, because these classical representation theorems don't, like that I have seen, don't directly represent observations at all, and instead make it more of an implicit part of how you would use the setup, we have to take a look at how people use these things. And when we do that, again and again, oh, this gray is much later than I intended, but that's okay. Again and again, we see the partitional evidence assumption. And so this is just some places where we see it. Like Amen just clearly spells out the assumption in his papers on common knowledge and the agreement theorem. It's more of like a implicit thing in like Solomonoff induction and AIXI. Information theory relies on it, and Cartesian frames explicitly make something similar as part of the definition of what it means to be an observation. There's some work on relaxing this thing, but yeah, what the heck am I talking about? What's the partitional evidence assumption? So the idea of partitional evidence is that you have your like event space, and evidence somehow partitions this cleanly, meaning that each of the propositions, which could be an observation, here, where's the whiteboard markers? Okay. Thanks. Yeah, so just to draw a simple picture of that, it's like, here's your whole space, and here would be some partition, whereas if you have something like this going on, then it's not a partition because these sets overlap, and so the three axioms I'm going to talk about it in terms of this function, which is the evidence at world W. We can also talk about it as a relation, the evidence relation between world A and world B. But so the evidence at world W is like the proposition of everything you know if you're at world W. But instead of thinking of it as a proposition, I'm going to think of it as a set of worlds. And so E of W is like the set of worlds that you think you could be in if you're actually at world W. And so the first assumption is reflexivity, which means W is in its own set. The second one is transitivity. So this is like, if X is in the evidence of Y, Y is in the evidence of Z, then X must be in the evidence of Z. And then, of course, we have symmetry. So if X is in the evidence of Y, then Y is in the evidence of X. And so these are probably pretty familiar assumptions to all of you in terms of assumptions on relations. And of course, if you have all three, then it's just an equivalence relation. So it's some kind of equivalence relation on worlds, which is equivalent to saying that this is a partition function, which selects out the partition of all the equivalent worlds. And so what kind of the main point I want to make today is like, all three of these assumptions seem very questionable when you start thinking about them. I'm not sure which ones I really want to deny. I'm just kind of making the point that all three seem kind of fishy. So reflexivity might sound like the firmest one. Like, of course, W should be in E of W. But from the outside of the agent, it's like saying that whatever the agent infers must be true. Like, if it thinks with absolute confidence that its sensors have put it in a world where, like, the temperature is above 80 degrees, say, then it is just, like, absolutely correct about that. And this seems kind of fishy, right? Like, it seems like if we take this position that the sensors tell it something about the external world, then the sensors should always be fallible. The sensors could always be telling it the wrong thing. And then from inside of the agent, like if the agent believes this about its own observations, then we can kind of problematize this by thinking about Loeb's theorem. So, general point, I've given these assumptions in terms of properties on the relation, but we can translate these into properties of a modal logic of, like, knowing, like what the agent can conclude from its situation is like box A. Or like, what it kind of, I don't know what to call this box, but let's call it knows. And so it's like the reflexivity axiom is saying that if I know A, then A. And then the transitivity axiom, so this is like box removal, and this is like box doubling. Like, if I know that A, then I know that I know that A. And then the symmetry axiom turns out to be like, if A, then necessarily possibly A. And I'm not going to get into explanation of how all those translations happen. So I guess you'll have to trust me on this one. But yeah, it's got me to face.
So what's the form of you're asking to trust here? Like, is there some really solid math behind the translation, or is it more vague?
So I'm talking about like Kripke frames. I'm talking about like we take the evidence relation to be like the accessibility relation in a Kripke frame. And then there's like a soundness and completeness type thing. So actual math. And then if we take the form of Loeb's theorem for modal logic, then this is a bit fuzzier, but it's like, roughly speaking, if we assume transitivity and we assume self-reference, so like the diagonal lemma of Gödel, and we assume that transitivity is not just externally true, but also the agent knows that it's transitive. So it's not just whatever we know that we know, it's also we know that. Then we can conclude Loeb's theorem, which means that reflexivity, if we ever know that reflexivity applies to a particular proposition, then we just know that proposition outright. And so this is kind of like saying reflexivity is only true in the trivial case. Yeah, so this makes it kind of fishy sounding to, if we ever propose that reflexivity should be something that the agent itself assumes. You might think, oh, of course, like, maybe we from outside the system know that the agent will sometimes be fallible. Sometimes it will think 1 + 1 = 3. But from inside, of course, the agent just has to assume that whatever it observes is true, right? And this is saying, well, if it assumes that and it meets some other requirements, then it will simply think everything is true.
So it can't really believe that it's fallible.
It can't believe that it's infallible. If it believes that it's infallible, then it will be wrong about everything.
Right.
By
Okay.
standard kind of Gödelian arguments. Okay.
Is there a sense that I can take the 3 axioms being given in modal logic and conclude something like partition, from these, just taking these 3 axioms, nothing else without the
Oh,
theorem.
what's the statement of partition assumption in modal logic alone? That kind of thing?
Can you get, is there some theorems, well, if I have these 3 modal logic assumptions, then something, it looks like a partition?
I imagine so, but I'm not sure what to say.
Yeah, I can.
Cool.
I mean, Any 50 frame satisfying these three things has a transitivity relation that is an equivalence relation, i.e. a partition of the possible worlds.
Yeah. So here I'm saying like, okay, so I made some arguments for why reflexivity is fishy, but maybe we just want to make it as a theoretical assumption anyway, right? Like maybe we just need to assume this. And one way we can do this, which I kind of expect everybody to come up with at some point if they're arguing with me about this or something, is so I'm going to say retreat. This is like a claim that we're somehow retreating, which you might object to. Maybe you think we were already there in some sense. But we retreat to phenomenological evidence. I'm not sure what else to call this. This is what one paper I read called it. So the idea here is observations shouldn't be like temperature. I shouldn't have my robot have a sensor that senses temperature and then think it's observing temperature. Observations should be like observations should not even be the thermometer says, because the thermometer is this object in the world that I'm making a claim about. Observations should be phenomenological. If I see an orange chair, then there's no way that I can be wrong about that, right? Like, I'm not, like the seeing alone does not make a claim that there is an orange chair. It's merely a claim of an impression of an orange chair. And this impression does not imply any particular fact in the world. It doesn't even have a specific claim of like a particular thing is going on in my brain, because again, I could be wrong about that. Instead, I just have this infallible knowledge of what I myself am experiencing. And I'm not really sure what to say here, but I want to have like a discussion about this, because I feel like this is something that we as Bayesians retreat to without necessarily thinking about what we're giving up in doing so. And also we could kind of make this lobe point again where like, but then these observations, wouldn't they be something such that observing A necessarily implies A, and therefore we believe all of them, which would be wrong. I'm not observing red and blue and yellow just because individually it's true for each of these things, that if I know that I observe them, then I observe them. And so there's something weird going on there again, yeah?
I know, maybe we'll talk about this later, but I'd be interested to hear more about how this assumption shows up in these theorems, and you said they show up in ominous agreement theorem and Nike and all these things.
I actually don't have like slides later, so that was just like a claim at the beginning to support that this is common. So I could talk about that. I still have quite a bit of time. So backing up.
Yeah, because I'm like, well, yeah, how does this actually in practice?
So Amen, as I said, he just transparently assumes this as a necessary part of his framework. So like with this like evidence function and everything. And so it's like part of how Amen's agreement theorem is proved, and it's part of the framework for thinking about common knowledge. And since I don't have slides on those things, I suppose I can't go into more detail on that easily, but Salmanoff prior and oxy, basically they get this assumption in through the sequential prediction framework. So it's like, because we assume that you have these binary observations, you see a 0 or a 1, there's no weird in between thing, and then you just get these in sequence. So it's like you have this like space of infinite bit strings that just, I mean, it's really like your whole event space kind of, but then you also have the algorithms.
How would it look if I don't make this assumption?
Yeah, I mean, so this picture over here was supposed to kind of clarify this, but I guess it's not very concrete, right? So I will actually get into some examples later, but well, let me just jump to it. So if I, as a child, I know that I'm thirsty if I'm thirsty. But if I'm not thirsty, then I don't know whether or not I'm thirsty. Then I violate the partition assumption. Yeah?
In sequential prediction, we do have something that's kind of like not partition, because if you observe a 0 the first time step,
Yeah.
you could then subsequently observe 0, 1.
Right. So you actually have this like tree.
Yeah.
Yeah.
Does that go far enough? Or?
I mean, it's an interesting point, but in terms of the sort of things I'm thinking about, it's like not nearly far enough, I guess. Because it's like you can still slice and dice your observations very nicely. Like, it doesn't question reflexivity at all, right? Like I'm interested in this sort of deeply self-questioning agent. I don't necessarily know how to think about it, but yeah.
So I'm trying to think of some example, I guess, in the back of my mind. Could you help me, like, to see if this is in line with what you're trying to get to? So I'm thinking, say, if we have some physical system that is supposed to give me a reading of temperature, we might say, well, in this range it's supposed to give me a reading, say, in this temperature range. In this range it's supposed to be giving me a different, perhaps, like, temperature range in this other range, whatever. And that should be, say, some subjective function, if in the simplest possible case.
Yeah.
Now, if my, say, thermometer was very noisy, it might be that for the same reading, I'm getting, say, for the same state of the physical system, I'm getting different readings.
Right.
So in that case, basically, the partition assumption is violated just because the thermometer is noisy.
Yeah.
Would that be a good example?
Yeah. And I want to argue that this violates transitivity, but maybe you can model it different ways and it would violate different axioms. But to jump ahead to transitivity, so the argument I'm making here is like, you have a coffee cup on the table, and you as a human say, well, I can observe the coffee cup's location, but any sufficiently small move is identical to me. And of course, this is like a modeling assumption I'm saying, not just from this particular location a sufficiently small move, but there's some epsilon such that from any location on the table, a sufficiently small move would be indistinguishable, right? And so I'm kind of saying it's not like pixels, and this is similar to the temperature case, right? I'm not saying like I would observe it here, and then there's some small move such that suddenly it jumps over here. I'm saying no, there's some sufficiently small move such that It's always indistinguishable. But maybe this is unrealistic. Maybe we should do the noise thing. It gets complicated. But to make the argument, if we grant this assumption that any sufficiently small move is indistinguishable, and we want to assume transitivity, the problem is we can chain together these small moves to argue that we cannot distinguish between any locations on the table, right? And so this is the sense in which I want to argue that transitivity is questionable. I'm like, well, it seems to me like we can have these situations where we have these small things that are indistinguishable, but then they kind of add up into large things. And similar to some other things I'm saying, this might sound irrelevant for digital machines, because maybe the digital machine uses a camera that uses pixels, and so you really think of it as moving from one to the other. Or if, like, the black dot is here, then it's like a small move, like the black dot has some size, and therefore a small motion will change the floating point numbers that you get here. And then, like, floating point numbers are a discrete but pseudo-continuous representation. And so maybe that's a bit fuzzy, but maybe if we imagine it's integers instead, so you get some integer brightness back, and then you can just distinguish this is exactly this integer versus that integer. And so again, maybe you say, so this argument against transitivity might seem relevant for like humans or something, but for digital machines, it sounds irrelevant. And my response to that is like, but it actually comes up when we start trying to do embedded agency type stuff. Specifically, it comes up when we try to have some kind of access to our own beliefs, or we try to imagine an agent with some kind of access to its own beliefs. Then, because we have these self-referential sentences, x, which says that p of x is strictly below 1/2, then if we had this kind of digital access, there would always be some boundary like this, like 1/2 or 1/3 or whatever it is for the particular representation, such that if we have discrete knowledge of which side of the boundary our probability lies on, then we have a paradox, because we cannot consistently assign a probability. Did that make sense to people? Okay. And so in this case, then even though we're working with digital systems, we need to artificially induce this kind of fuzziness, this like inability to strictly distinguish. And so we need those transitivity violations in practice. I'm going to go back to Oldenziel's question. So, information theory, we get a similar thing to the sequential prediction idea, right? So, like in information theory, we have this assumption that we can make this coding function that is one-to-one. We have observations coming in, and then we can write down these symbols that losslessly encode the observations. And this is kind of where the partition assumption comes from in that case. And I'm forgetting the name right now, but there is a book. There is some work.
Sorry, I don't get that. The assumption that we have a coding function, lossless coding function, is a partitional.
Yeah, so go back to this like Venn diagram case and say like, I want to encode, like if I'm in this case, I can write like a symbol for each of these events, right? But if I'm in the Venn diagram case and I want to write a symbol for both of these events, then I have to conflate them with each other. I have to be like, well, if this is A, because this overlaps with A, this must also be A, or something like that. Does that make sense?
I saw an observation, but I'm not quite sure whether it's A or B.
Right. And so I have to have some policy. There has to be something I do. Like, I encode these things in memory somehow. But it can't be a one-to-one function from the possible observations to codes.
So, okay, so just from my understanding, the assumption of partition, the partition assumption is the assumption that all observations are neatly partitioned into sort of bins.
Yeah.
And you're saying kind of in practice have these vagueness, the edges are a bit vague. And,
Yeah, I'm saying we can point to these cases where we can't quite bend things for one reason or another. And so we should be aware if we're making this assumption that it really is a significant modeling assumption. Yeah? Or maybe you were first? Okay.
Yes, not answer the question. In the case on the right, could you not just like call it a new, the overlap, instead of well, so you recover partition. Right.
Yeah. So this is like the argument I want to make, I think, is like, yeah, you can always do something like this. But this is really assuming that the agent has additional resources in some sense. So like, I gave that example earlier of a child who's like, if I'm, I don't know, I feel like I had this experience as a kid of like maybe I know if I'm thirsty, but if I'm not thirsty, I don't know whether I'm thirsty or not. But then maybe I grow up and I become more skilled. And my boundaries become less fuzzy. But I would kind of, I kind of want to make some intuitive case of like, even as I defuzzify my boundaries, I increase my resolution on the world, I still will have more cases where I'm still going to be fuzzy. And so I intuitively kind of want to argue, this isn't like some kind of strong mathematical argument, but I intuitively want to argue that this is some kind of logical uncertainty phenomenon where if we kind of had unbounded introspective ability, then yeah, we could always do that. But because we don't, we will always have some fuzziness. And I guess a formal version of that is the introspection on probability thing. We can always increase the degree to which we can see our own probabilities perfectly, but we can never hit that like complete perfection so long as our algebra has these self-referential things in it. And so again, this is like one of the major assumptions of Loeb's theorem. We can also just cut out that assumption, in which case I think we can do everything. But that's giving up a lot of expressive power in our own belief algebra. And so I was going to say there is some work on removing the partition assumption from information theory. But that work does it by, I'm jumping around now. Oh, do I not have this slide in here? Oh, well, I'll just say it. So the work on removing the assumption from information theory is doing this thing which I will call the meta update. Not sure if there's a better word for it, but it's like, normally I would make the update like P of whatever given this event that encodes all of my evidence of the particular world that I'm in. And this is the regular update. The meta update is like, instead I update on the fact that my evidence equals this particular event. And so this is like, yeah?
What is the difference between these two? Like, just looking at the notation, these look the same.
Okay.
Like,
So
shorthand for the second.
here I'm updating on, this is like my event proposition. Here I'm updating on the actual proposition E of W. So this function, like I said, it takes us to a set of worlds, which we can regard as a proposition. And I'm updating on that proposition. Here I have a term which is my evidence today, what I know right now. And I'm saying I'm updating on the fact that that term equals E of W.
So like if blue blobs are a really common hallucination, it's the difference between taking the blue blob at face value and going, I see a blue blob.
Yes.
Probably hallucinating.
Yes,
Right.
exactly.
Do you need some good, like if I would formalize this properly, do I need some Goodlean encoding or
Do I?
for the meta update?
Oh yeah, that makes sense. I should put like brackets around this. Because this is now a term in my language instead of a proposition.
Would it be fair to say that the meta update is you're updating on the set of worlds in which your evidence is?
Exactly, yes. And so if we go over here, it's like, if I'm in A, right, I labeled both of those A, which is not very useful. So if I'm in A and in B, then it's like I should get A and B, right? Therefore, if I only see A, then the regular update would be, oh, I'm in A. But the meta update would be, I'm in A and not B.
You know what the transitivity argument kind of reminds me of? Continuity. Like there's no continuous function from, I want to say like continuous spaces like R or a probability simplex or something to, the sorts of spaces that are like a bunch of dots, like, the 5-element set or Cantor space or something.
Yeah.
There's no continuous function from continuous spaces onto those.
And
It's a
so,
little dubious to basically be taking continuous space and being like, here is a partition of it.
this marker has no back. So one argument you could make, I'm not sure if this is an argument you should make, it's an argument I've seen made, but it's like, we live in continuous physics, so why should we model ourselves digitally? Like, maybe instead we should think of like sort of fuzzy first foundations. Like, we are manipulating continuous variables from the start, and so we should model ourselves that way? Maybe. Yeah. So where do I want to flip to next?
So
Yeah.
just to repeat my understanding now, if you have this regular update and you have this meta update, which, I mean, if I mathematically instantiate it, it actually uses the Go encoding, so it's quite non-trivial.
Yeah.
And you're saying, if I now combine that with the fuzzy boundaries, these vague boundaries between events, I don't have partitional evidence, then they actually have different behavior. The regular update gives me A and B, and the meta update removes the A and B.
Yeah.
Okay. Mm-hmm.
And so, with respect to the coffee cup, if you perform a meta update, then you're getting even more fine-grained information than your perception is telling you purportedly, right? Because it's like, not only do I know it's here, I also know that it's not here where I'm making this motion of the very small move. Or something like this. And so we can actually re-specify the partition assumption, the whole thing, as saying that just our update should already equal our meta update. Yep.
For the meta update, should I not still update a little bit that it could say, like I want to update? Like if I observe A, I'm still getting some data about being in the intersection, like then outside of the intersection. Or then outside of non-vehicle.
Sorry, are you saying therefore the meta update is wrong, or are you saying?
Well, so if the meta update says I'm only getting evidence towards being in the only A, then I'm like, well, but I'm also getting a bit of evidence about being in the A and B intersection as well. I'm getting more evidence about, yeah.
So I guess how I would think about this is, if we really could do this meta update, if we have the resources as an agent to notice, I'm seeing that I'm in A, and I'm not seeing that I'm in B, and I would see that I'm in B if I was in the intersection, then I must not be in the intersection. But the problem is, maybe we somehow don't have the resources as an agent to do this.
Or we're still assuming away fuzziness. Like I'm still.
Right. We're kind of assuming like infallibility here, and yeah, assuming away fuzziness. So to me, this is like the difference between denotation and connotation. Kind of, right? So it's like the regular update, we just take this literally. We update on A. And the meta update, we're like, oh, why are they telling me this? We're like, or maybe not denotation and connotation, but denotation versus implicature. Yeah, and so we're kind of saying like, like I only get this from whatever system tells me things. I only get this in these certain kind of situations. Therefore, I'm going to make this inference that's not in what I'm explicitly being told. But to me, this is like, in a lot of contexts where we would care about this stuff, this is going to be cheating. Because we've only observed that we're in A. We don't know how to observe that we're not in the intersection of A and B. Like, if the update equals the meta update, then we just have the partition assumption again. We basically divided these two parts into the three parts that turn them into a partition. And so I want to argue against this approach to information theory that relaxes the partition assumption, because it's like, well, yeah, it kind of relaxes the partition assumption, but it kind of brings it right back.
Sort of like a narrowing down process. Like in my visual field, I can observe this chair. I can make inferences about stuff, depending on, the state of the chair I am observing. But there is also other information that I am not considering. The total sort of bundle of evidence that I am acquiring, I am only using a part of it to narrow things down, and not necessarily all of it. Not attempting to whatever evidence is over there with chandelier.
Yeah, so removing the partition assumption kind of gives you this ability to float around and I'm not assuming that my eyes are the device of my perception. Maybe I can think of my conscious perception, or maybe I can think of something else, which I don't know. Sorry, yeah?
Yes, I feel like the meta update implies some kind of certainty about what kind of thing you are. Like, if you introduce uncertainty about the kind of thing you are, you might recover something. But you do something more complicated than the meta update, which also includes, I don't know, uncertainty about how you encode the fact that, you saw this. Where in the case of the A and B thing, it's you can't really do the inference that you didn't see B because there's a whole different set of things you could have not seen, depending on the kind of thing you are.
Right. It's I assume not only that I know, not only I have access to this,
yeah,
but I have access to that whole hypothetical.
Exactly. And it's but maybe we can still say something about the space of hypotheticals, spaces of hypotheticals we considered.
But I had a similar thought, which was something sounds like I kind of want to make updates in virtue of the sort of thing I am, including things my positionality and how good my sensors are, my place in history or whatever. And then, but the problem then might be that feedback loops on itself, right? I also, for the same reason, I don't have very good access to the sort of thing I am. I'm not certainty over that, and I have the same sort of issues that you outlined there over the question, what sort of thing I am.
Right.
And then the question is can you recover anything? So this is more speculative, but you might do a sort of move of well, in order to be observing anything, I need to be a thing. Something about things, something about boundaries that allow me to, or I need to be instantiated somehow to be even perceiving something. And given that, my introspective observations need to at least have some coherent relationship to each other, and there's sort of a neural type thing I can bootstrap from that. And it's maybe still extremely loose, but I think given that I'm a thing that can even observe something in the first place, there's some coherence between my observations relative to each other, and then there's my round out the
I don't know if this is the right association, but with respect to this phenomenological observations idea, how do we think about the negation of that? The position is called something like externalism. If I see a chair, I see a chair. I don't just see the impression of a chair. I'm actually seeing this idea that we actually do reach outside of ourselves. This notion that we are these Cartesian, outside of the universe things that can never fully get actual information is negated, and instead we see, oh, I actually am touching a piano, and I know that I'm touching a piano, but my knowledge is fallible suddenly, right? Because I can be mistaken that I see a chair, but I do see a chair in this case. In some other case, it might be an illusory chair. And so this perspective kind of makes more sense if we're starting looking at agents from the outside, and we say, oh, something is happening to the agent, like light rays are hitting it, or like it is in a physical situation, and it is kind of, we start modeling it saying like, oh, it's updating on this situation. And it also kind of makes sense from the position we actually find ourselves in, because we don't start out saying, oh, I only observe these tiny little dots of light, and then I put them together into objects. We start out saying, once we know how to speak, oh, there's a book, oh, there's a table. Like, we kind of start from these physical events that in pictures such as Solomon-Off induction, we think, oh, we don't have access to those have to be inferred. But we can actually model things the other way around and say, like, we update on these things, but our updates are fallible. Of course, this is like kind of a non-computational picture, because how do we come up with these things in the first place? But I think I'd better move on. So I did reflexivity, I did transitivity, I kind of did symmetry, but I'll reiterate a little bit. So my favorite quote about transitivity. So Eliezer says, some people might say, many people while dreaming are not aware that they are dreaming. Many people while dreaming may believe at some point that they have woken up while still being asleep. Clearly there can be no license from I think I'm awake to the conclusion that you actually are awake, since a dreaming person could just dream the same thing. So this is like a symmetry argument. This is saying, if while dreaming, I think I might be awake, then it must be because of symmetry that while being awake, I think I might be dreaming. And Eliezer says, no, those who dream do not know that they dream, but when you are awake, you know that you are awake. And if you take this quote seriously, then you should doubt transitivity.
Right, but in the second one, we in principle don't know that we are awake, right?
If you buy the first one.
Now, I'm pointing at the second one and the condition that when you are awake as something that is maybe at least up to debate.
But I think you're arguing for transitivity. Right? Sorry, symmetry. Right? Like, you're saying, oh, how can we know that we are awake? Right? And I'm saying, well, we're awake. This is not a dream. We know we're here. It's kind of a bold statement, but...
Right, so that's an argument, but this is more of an axiom.
I
choose to, okay.
I mean, so...
On this level of dream, I choose to say that I'm awake.
Right.
I feel like you can say something like that.
Say what?
You definitely can say something like that.
Right. Like what Eliezer says is something like, we have, like if you, like this is a metaphor, and Eliezer is actually talking about, should he a little bit believe somebody's BS if they don't even know the math to do the calculation they're trying to do, or something like this. And he's like Robin Hanson wants to argue something like, well, if that person is overconfident, they think they know the math, but actually they're just doing some ridiculous chicken scratch, then you should have some probability that you are overconfident. And Eliezer says, I'm actually doing the calculation. I can show it to you. This is the source of my confidence. It is true that if I did not understand this calculation, I might do some chicken scratch instead, but I actually do know the calculation. And I can show it to you, and I understand why I am confident. Again, you can ask the same question. You can say, but that's the same thing the person with the chicken scratch could say. But that's this external perspective of like, from somebody who's taking this kind of hands-off agnostic approach, they're pretending that they can't judge the math directly. Then they have to say, like you're in the same reference class as this crackpot. But from the perspective of somebody who does know the math, then you can distinguish. Yeah?
These arguments you have simply only apply to certain kind of statements that are self-reflective. So this is, I could be dreaming, I could be making a mistake with maths, I could be hungry. All these refer to, I'm thinking about how I'm perceiving, how I'm thinking, how my computer is working. But if any other kind of statement, I can be like, okay, so maybe I'm making a mistake, maybe I'm confused, maybe I'm just really tired and I can't think through this properly. But I think that I know any of these things, I think I'm thinking clearly, then any kind of other statement, this doesn't apply to me.
So we can reformulate symmetry as negative introspection of, for any world W, if the evidence at W does not entail some proposition P, then the evidence entails that it does not entail P. This is from a paper by Nilanjan Das. And we can similarly reformulate, transitivity to positive introspection. This is kind of obvious from the modal formalization that I've already given, that necessarily P implies necessarily P. So like if I know P, then I know that I know P. And so kind of every case of these two axioms is about introspection already. It's like to ask whether symmetry applies is to ask whether I have the negative introspection, to know what I don't know. And to ask if transitivity applies is to ask whether I have sufficient positive introspection. And I guess I will speed through the rest a little bit. So
Did you still have a question, Noel?
I'm just going to speed through the rest. So why does this matter? This is like my second motivation slide with more detail kind of. So reinforcement learning has a wireheading problem. We have like corrupt feedback. We can never rule out this sort of wireheading hypothesis. Like we're trying to teach the AI to do good things by the human standard of good, but all we can do is push the button when we think what it does is good. And so it will always be at least as high quality a hypothesis for the AI to model the reward as when the button gets pressed, then things are good. And then it just wants to try and press the button. Or if we manage to rule that out, to get it to understand, oh, it's the human pressing the button that's good, not the button itself. Then it's going to engage in human manipulation, which is really just the same kind of error on another level, right? And so I want to kind of argue that there's a sense in which this is because it's assuming that there's some ground truth that it has some kind of access to about what is good. And then you have the hypothesis space that is like the rest of the event space. So you have these these events, whether they're partitional or not, but usually we assume they're partitional. You have these events that define this ground truth of good. And then you have the rest of the event space that's off doing its hypothesis building thing. And because of that, we can never rule out these bad hypotheses that do not mean what we want the AI to learn. Because all we can do is give feedback on this part. What we want to do instead, I claim, is give feedback on the whole event space. We want to be able to tell it arbitrary pieces of its beliefs are bad. And here's where the partition assumption comes in, because if we give it feedback on the whole event space, we cannot satisfy the partition assumption, because the whole event space is going to include things like A and C, in addition to A and C, right? So if we have this rich feedback ability to be able to rule out things like wireheading, then we violate the partition assumption.
So what do you mean by feedback? Feedback for the whole event space?
However we're training the AI. What's the question?
Maybe you just go on because you don't have
Yeah, so time's up. Should I like power through, or should we just say it's...
No, I'm very strict. I'm very strict. You have 3 more minutes, I think.
Okay, so yeah, I wrote these posts about the learning normativity agenda, which is kind of about this. Then I have this section which we don't have time to get through, which is why we think we need the partitional evidence assumption, which is because of the problem of filtered evidence, which we kind of did talk about. But like the reason why people want the meta update to equal the update is this classical Bayesian problem of dealing with filtered evidence. And then I make this argument that in like the untrollable mathematician, it's like the argument due to Scott, when we update on mathematical things, we always have this problem of our beliefs oscillating. And then Sam came up with a solution which prevents this basically by like having our updates equal our meta updates. But this prior that Sam offered is dumb, and it turns out to be a general property of such priors that they're dumb for computational reasons that I don't have time to summarize. And then I make a pitch for radical probabilism, and then that's the end.
Thank you for a very interesting talk. I'm happy that we have another slot for people really ask a question. But I think we have time maybe for 2 short questions, if there are any. Yeah.
Rather than questions that are pitch for, could we have the next session in here so we can get the slides?
But it's so hot in here.
Okay, Matt? Oh, yeah, great. Look into that. Other question?
I made the decision that the whiteboard is going to live there.
Yes.
Because we're going to need it.
No worries. The prices are back.
Oh.
For both the, like, comparing symmetry and anti-symmetry and comparing the regular update and the meta update, I feel like I have some like meta uncertainty that makes me want to be able to talk about kind of wanting to make updates as to whether I'm making regular updates or meta updates, or updates as to whether I'm making like in a symmetry type world or an anti-symmetry type world, which is like different to the it's like a meta update. I don't know, symmetry levels or something.
I don't understand yet.
So when we're in with the symmetry and symmetry case, like I don't know, I feel like there's something of like self-doubt always being healthy, but also having confidence is really good.
Yeah, like I'm this isn't responding necessarily to your point, but I'm like, Yeah, this argument for symmetry does feel somewhat compelling,
Yeah.
but I'm also somewhat drawn to the argument for anti-symmetry. So I'm
I
like,
think there's something similar going on with the relationship between regular update and meta update.
hmm.
And I'm like, I kind of actually want to do those.
And similarly, I'm drawn to Eliezer's argument in inadequate equilibria, but I'm also drawn to Robin Hansen's argument for basically the opposite thing in uncommon priors require origin disputes.
I'm going to cut you off right there.
I think
I'm going to cut you off, yeah. Let's thank the speaker again.